Hey everyone, welcome back to the channel. In today's video, I'm going to take the database diagram that I drew in the last video, and I'm going to translate that database diagram into actual SQL statements that we can use to create these database tables inside of Postgres. Once we have the tables created, we will write some Python code to populate these tables. So we're going to get some stock information from a REST API. So we'll probably just use Alpaca since I've used it a lot on this channel, and most of you probably have an account because it's free to sign up. And so we're going to populate the stock table, and then we're going to go to the ARC Funds website, download the CSV files that contain the current holdings for those funds, and we're going to populate an Etf Holding database and all of the relationships between these two tables. And not only are we going to look at the current holdings of the ARC funds, we're going to download this data for multiple days and track how the ARC funds are changing over time. That way we can see which companies is ARC funds, which companies are they investing more in and increasing their weight and exposure to, and which ones are they selling off and removing from the ETFs. So which companies are being added, which ones are being removed, which ones are they increasing their position in, and we're just going to use that as our example to start working with some time series data. And this is just going to be date data so far, but then in the follow-up video, we'll continue on to prices and talk about minute data, aggregates, and all those functions that I mentioned. So let's go ahead and get started with writing some SQL code. All right, so here I am. I have Visual Studio Code open as usual, and I'm just going to open and just create a new folder if you don't have one already. So mine's called ArcTrack, just a regular old folder on my desktop here or in your projects directory. And I'm going to create a couple of directories in advance here. So I'm going to create a directory for data. And I'm also going to create a directory called schema, or we can call it DB, whatever you want to call it. And so in this data directory, I'm going to download our ArcETF data, our CSV files, and store it there. And in this DB directory, I'm just going to store our SQL scripts. So the SQL we write to create our tables. And so I'm going to create a new file just called create_tables.sql, just like that, right? And in here, I'm going to go ahead and create a few tables. And what tables am I creating? Fortunately, last night when I was thinking about this, I drew a database diagram, and whoa, looks like someone had a couple drinks last night. Kind of messy, but you get the idea. Hopefully that all made sense. So we have a stock table with an ID primary key, a symbol, name, exchange, and ETF. And I talked about the different types of data that are being stored in here. And so what I will do is write the SQL to create these tables. And so you just use a regular create table statement. And if you want a full introduction to SQL, go to the website and go to the Full Stack Trading app. And I've actually written all of this down about how to create a table, how to select, insert, update, delete records, that kind of thing. And that's a good overview of SQL. But I'm going to assume you know some SQL at this point. And so I'm going to use a create table statement. And this will be very similar to what we did in SQLite. But the Postgres edition has a little bit different syntax or data types mainly is the difference. So you just have a create table statement and you type the name of your table. And so I have a stock table, an ETF holding table, and a stock price table. And so I'm going to create table stock, and I'm going to create a table ETF holding, and I'm going to create a table called a stock price, right? And that is all good. And so I want to create the stock table first because that's the base table. A lot of these tables are going to reference the stock table. So the stock table has to actually exist first for us to reference it. And so once we've written these create table statements and put these parentheses here, we need to define the actual columns in the table. And so I called them ID, symbol, name, exchange, and ETF, right? And so I'm going to put ID here, the data type. So I'm going to use a serial primary key, and this gives me an auto-incrementing integer. And so when I insert a record into this table, it'll start with the number 1, 2, 3, and 4. And it's just an easy way to reference a unique record in the stock table. Okay, I'm also going to create a symbol column, and this is just going to be a text column. And you can specify that this is not null. So if you try to insert a record with no symbol, it's going to be like, no, you can't do that because you need an actual value here. So it performs a little bit of validation for you on the type of data that goes in here. Okay, each stock has a symbol. It has a name, which we're just doing as a text field as well. And we're going to also have an exchange. And we don't really need this for this tutorial, but I'm putting it in there. Text, and we'll just use text since it's not that important here. We're not going to create a whole exchange table for all of the exchanges because that's not really the point of this video. And we'll do is ETF, and this will just be a true false value, Boolean, not null. And this will just mark whether or not this particular stock is an ETF, an exchange traded fund or not. So ARKG would be an ETF, SPY would be an ETF, QQQ is an ETF, but Apple is not an ETF, right? And moving on, we have the Etf Holding Table, right? And this stores our relationships between ETFs and the stocks that are in that ETF, right? And so I called these fields ETF ID, Holding ID, DT for date time or date, whatever you want to use, shares, and percent, okay? Or shares and weight. We can use shares and weight, okay? And so for this one, we're going to use ETF ID as the name, and this is going to be an integer, and this cannot be null. We're going to use a stock ID. It's an integer that is not null. And remember, this ETF ID and this holding ID, they're just references to a stock. So as soon as I insert a stock with an ID of 1, we're going to have a record in here for like ETF ID 1 and maybe holding of stock ID 2, right? And I'll insert some example records in a second just to make sure that makes sense. Okay, so ETF ID, we need a stock ID, or I called it a holding ID here. And then also we're going to store a date time, or just a date field. I'm just going to use a simple date field for this. So nothing unique to timescale on this table, right? It's just a date, and we're going to use that as a way to introduce tracking data over time, right? So we have a date time, and we're also going to have shares. So the number of shares that the ETF holds of a particular holding. And this is just going to be an integer or numeric. I think they actually have fractional shares now, so it's good to have a numeric field that can store a fraction, like 1.25 shares, things like that. For some people that can buy a fraction of a share of Amazon. Some people don't even have enough money to buy a share of Amazon, so they can buy like half a share or something like that. So that's why that's a numeric field and not an integer. And also the ARK ETF stores these as decimals as well. So I'm going to say numeric, not null. And I'm also going to store the weight, and this is going to be numeric. And actually I will make them nullable, so I'm going to make them nullable. So you might want to use this to store SPY or some other ETFs that you don't have data on their holdings, like the number of shares they hold. So I'm going to make that nullable so you can use that for other ETFs if you want to. But for the ARK funds, we're going to use these fields. So we're going to allow them to be null, okay? And then, so for this table, how do we uniquely identify one of these holdings? We're going to use a compound primary key. So whereas this one is identified by an ID, just a regular integer, what makes this particular row unique is the ETF and holding ID. So ETF 1, right? You can have ETF ID 1 over and over again, right? So that's not a unique way to identify a record. And it can have multiple holdings, so it might have a holding for ID 3, 4, and so forth, right? And so these are just comments. And so I could say 1 is ARKG, and the holdings are crisp, and then this would be a record for 1 ARKG, and then edit, and then maybe it's 1 ARKG, and I think Teledoc is 1, right? And so we're just storing the relationships in this table, right? And so the way to uniquely identify these records is we're going to create a primary key. So we're going to type primary key, and we're going to say that primary key is a combination of the ETF ID, the holding ID, and the date and time. So we can have the same record of ETF and holding ID, but also we can have multiple dates, right? And so if we want to access a unique record, we can access the ETF, the holding, and a particular date. So we're going to have multiple records per holding in the ETF for every single day, right? That's our primary key. And for stock price, you should be familiar with this if you follow the full stack tutorial. Very similar. We're going to reference a stock ID. Okay, so we're going to reference a stock ID. So there will be a bunch of prices in this table, and each of these price records are going to reference a particular stock. And so this will be an integer that is not null. Okay, and this is going to have a date time, which is a type timestamp. So we're going to store minute data in here, and we can roll that up into hourly data or 5-minute data, dailies, monthlies, and so forth, because Timescale has functions for all that stuff, which I will demonstrate in probably the next video. Okay, so timestamp, and then you type without, I'm going to do without time zone, not null, so it needs to have a time, and we're going to do open, high, low, close, and volume. Done this a million times on the channel. So open, high, low, close, and volume. So for that particular timestamp, what did that bar open at? So Apple was 111 at 10:05. It might be 112 at 10:10, and so forth, right? So, and we're going to store the volume data in there, and these are all going to be numeric, right? Numeric, not null, and then we'll just do numeric, not null. And you can null these if you want to. There might be a case where you're storing like the beginning of a bar, but you haven't stored the close yet. So in that case, you know, you'll want to allow null values. But here I'm just going to store completed bars inside of the database, so they should each have an open, high, low, and close already. Okay, and then the same with volume. I'll do numeric, not null as well. And the primary key in this case is going to be a combination of the stock ID and the date and time, right? Each of these records is unique because they refer to a particular point in time for a particular stock. And we're also going to add a foreign key constraint to each of these tables. So I'm going to type constraint. And you don't have to type all this. If you want to just download it from GitHub, I'm going to post the code right after this, and you can just copy it from github.com/hackingthemarkets, right? So I have constraint, and I just name these, and I do foreign key stock, and then I type foreign key stock ID references stock ID. So I'm specifying in this table, the column stock ID is a reference to this particular stock. And it looks like I probably need the same thing up here, right? So I can specify foreign key ETF ID or whatever, or foreign key ETF is a foreign key stock ID. So it'll be ETF ID in this table, references stock ID, and we also can have a constraint for the foreign key for the holding, and we'll do foreign key holding ID and references the stock table as well, right? And what's nice about this is what we can do is specify different referential integrity constraints here. So I could do something like on, delete, cascade. So there's a number of ways to set this up. I'm not going to put any special constraints there, but what I can do here is say specify when a stock is deleted from this table, that it should be deleted from all the holdings, and it should be deleted from the stock price table. Or I can say null them out if I want to keep these records around. A lot of different ways I can specify what to do when a record is deleted. So that's our foreign keys constraints. And it also validates that I don't insert an ETF holding or a stock price record for a stock that doesn't even exist, right? And a database like MongoDB or just some other structure, like if you're just using CSV files, right? You can have data all over the place that refers to things that no longer exist, and then you try to access them and your program blows up, right? So pretend a stock gets delisted or the symbol changes and you have all these symbols lying around somewhere. And in the previous series, I talked about different ways stock symbols have changed over time. I think I used the example Vivendi. right? And that is a stock that used to exist a long time ago, right? And I think it was ticker symbol V, right? But it no longer exists. And then now Visa, V, a Dow stock, has that symbol. And so that's why it's nice to have these ID primary keys, right? So then we're not tied to just the symbol, because the symbol can change. It can be reused for another stock. Stocks can get delisted, that sort of thing. So that's a basic database structure. And then we can also create an index. So this can make scanning your table and selecting data quicker. So I could do like create index. And I'm going to gloss over this part a little bit, and we can talk about this more in the next video. But the stock price, this video is going to be mostly focused on stock and ETF holding here. And these are very simple tables that won't have a huge amount of data in there. There's only so many stocks, like 10,000, and then there's only so many ETFs, right? But the stock price table, as we've seen, can be like millions and millions of records, depending on how much price history we want to store, and the interval, whether it's like minute data or second data, right? Storing a lot of that data can take up a lot of space. And so I'll do create index on stock price. And so we're creating an index on that table, and then that index is on stock ID and date time descending. And so when we're selecting out of this stock price table, and so what this does, if you're unfamiliar, is make it faster to select prices for a particular stock. So it tells Postgres how to optimize and not like scan through the whole table in order just to find one symbol, right? And so there's a number of websites you can look at on this. So use the index Luke is a popular website tutorial that's all about database indexes, but the whole idea is like, think if you're looking through a telephone book, right? And you're looking for someone with the last name Johnson. Oh yeah, people don't even use phone books anymore, so it's an old school example. But if you're looking for the name Johnson or looking through the dictionary, and another bad example, right? Because who looks through the dictionary? You just look it up, right? But if you're turning page by page and you start your index finger at the letter A, right? There's no reason to start at A for Johnson, right? You know, you can kind of open it up in the middle and start at a particular point. Or same with the dictionary, you know, you can go directly to the J's, right? And so, yeah, so there's different ways to optimize your database and Postgres SQL, the planner, to make it faster to find the data you're looking for instead of scanning through 20 million records, right? Okay, so create an index, and then there's also this select create hypertable on stock price and date time here, and I'm learning this as I go right now, but in Timescale there is this concept of a hypertable. The point of interaction with your data is a hypertable, right? So it's an abstraction, I guess. So you create a table, and then if you want to use Timescale and all of the functions here and take advantage of it, then after you create a table with a timestamp, you want to create a hypertable on that table and specify your timestamp field. And if you want to dive into this concept a little bit more now, you can go to their documentation, go to hypertable management, and this goes very deep into database concepts and the lower level storage and chunking data and all of this stuff, which I haven't actually looked through all of this documentation yet. But some Timescale folks, I think, are actually watching this video, or they saw the last one, so maybe they'll leave a comment or comment on this a little bit more, make sure I'm using this particular feature correctly. So I'm creating a hypertable on stock price here, and this is all we need to create this database. And so I should have my Docker container running still. So in the couple of videos ago, I created the Docker image, right? Or I pulled down the Docker image, and you see that my TimescaleDB is still running. I have the Docker image here, and then I ran a command to jump onto my Docker container, and then I have in my history where I logged onto Postgres, and we created a database called EtfDB, and I can connect to that database just like that. And if I try to list out the relationships and the tables in there, there are none yet because we didn't create any yet. We just created the database, right? And so what I can do is execute this SQL from the command line, make sure it works. So I'm going to paste this right in, just like that. It'll tell me if I make any errors, which I did. And so syntax error near the parentheses on line 7. And you see it's probably this extra comma I have. And I'm going to paste that again, and it created the table. Now if I type /d, you see we have a stock table, and we have a stock ID sequence. And so this is what keeps track of that auto-incrementing ID that I mentioned, right? And if I do select star from stock, you can see there's nothing in it, right? Empty table, but here are the columns. If I want to insert into this table, I can do insert into and list my columns like symbol, name, exchange is ETF, right? And then I list out the values, which could be Apple, and the name is Apple, and the exchange is, I believe it's just NASDAQ, and I will say is ETF is false, right? And look at that, I messed that up already. So at the, I have to do insert into the actual table name. So insert into stock symbol, right? And now if I select from stock, look at that, I have an auto incrementing value. So number 1, Apple, NASDAQ is ETF is false. Basic database stuff. So if you know a lot about Postgres already, it's very boring and easy to you. You wanted to learn more about timescale, but I like to kind of start off and bring everyone up to closer to the same level so that we can work on this together. Okay, so I have a stock in there. I could do the same thing and insert an ETF, right? And so I can insert an ETF like QQQ, right? And say that's the NASDAQ 100 ETF. And then I could say is ETF is true. And then if I select all my records, you'll see I have this QQQ one. And then I can insert another one for MSFT, so for like Microsoft. And then that would be Microsoft. And we'll automatically insert all these in a moment. I just want to show you a few example records. Fast forward through this if it's too slow. And so I'm going to do a false there. And right, Apple, QQQ, Microsoft, we have one ETF, right? Stock table, good to go. And if I do /d in stock, I see the schema here. We see the not nulls. We see the sequence. We see the primary key. Cool. Good to go. Okay, next, I already have the Etf holding table defined. So I'm going to paste this guy in. And now, look at that. We got this Etf holding table, right? If I try to insert into Etf holding, I want to insert an Etf ID, a holding ID, a date time, shares, and weight. And let's say I just try to insert the values 5, 4, 7, current date, and then 1 and 2. Let's see what that does. See, I just made up those numbers, and Postgres told me the key Etf ID equals 4 does not exist. So it doesn't just take whatever garbage you try to put into it. It has to actually correspond to one of the stocks. And so since we inserted Apple, we can do, and we inserted QQQ. When you look up here, the Etf ID is 2 and the stock ID is 1. And so for QQQ, we have a holding of 1, and I'll do the current date and then just put made up values there. And now if I do that, you'll see that we have Etf ID 2 and holding ID 1. And then you could also insert a record for Microsoft for that ETF as well. And this current date is just a built-in Postgres function that gets the current date, right? And now if I select from Etf holding, we have QQQ, which is this number 2, has stocks holdings number 1 and 3 as of January 29th. And so now we have our foreign key relationships that we demonstrated, and we have our Etf holding table, and you can kind of see how we can use this date time to store the holdings of the ETF and its weight over time. Okay. And so what we can do now is create the stock price table. And actually, you know what I'll do now is use the graphical tool a little bit for people that are using a graphical tool. So I have this table plus here, and I can open, as of the other day, I opened up the database, right? And so I can click a database, open my ETFDB, right? And I should be able to see the tables. There you go, I have tables in there, functions. Okay, so I have the functions expanded, And then, oh yeah, so I have this connection open, and now you see my tables, and I can browse those tables. This is nice. I don't have to write SQL. Once you know SQL, then you don't need to write these queries all the time, but it's good to know the underlying language. But once you know that, then use the tool, right? And you can click around and just see them in a grid, and you can see our rows in the stock table and the Etf Holding Table, just like that, right? And so what I'm gonna do now and see if I can create another table. And so I can do this. Oh wow, so I click a button and I create the table that way. I actually don't want to do that. So if you want to just design your table that way, this is a way we could have done it. You could specify, is it nullable, column default, data type, ID, the relationships. And so maybe in a future video, we'll define tables this way to make it quicker and easier. But we'll just use the command line for now, or you can just write SQL directly in here. So I'm going to click the SQL tab. And then let's see if I can just paste this SQL right in. So I'm going to create the stock price table. Make sure that runs, right? Run current. Okay. Error near constraint. Primary key stock ID. And I need a comma, I think there. Do that. And it should have created my table. Let's see if I can refresh this somehow. I don't see it on the side yet, but I trust that it's created it already. And then I'm going to do create index. So I'll run this query. And you can run these all at once in a script as well, just from the command line. There's a way in Postgres to just run an entire SQL file, but I'm just doing this very slowly. And then this says it created a hyper table, and we'll find out more about what that means later on. Okay, and so I got that. Let me restart that. Not sure, I didn't see the button to refresh it, so I'm going to open this, click database. Okay, and then there's my functions. Okay, so there's my tables, and so that's in there. So looking pretty good. Maybe it would have automatically refreshed, or I needed, oh, there, maybe it's that button. Okay, cool. We'll figure, I'll play more with that in a moment. Don't want to slow this down too much. And oh my God, time flies. Look at that. I've already used about 30 minutes of time just creating this database and talking about SQL a bit. And so I think that's one full concept for this video. And I'm going to create another one right after this, where we're going to populate this table using Python code and Alpaca API. And we're going to fill up the stock table and also talk about how to populate the ETF table with the holdings over time. So stay tuned for the next video, and we're going to keep going. Here in my garage, I don't have a car. I mostly just walk around everywhere or ride my bicycle. But what I do have is this book on Python for data analysis.